All right, guys, what I've done is I've picked two of your homework problems from tonight, and I've gone ahead and I've put together another tutorial to hopefully help you maybe get a little bit more understanding now that you're at home. Maybe you can focus a little bit better. So remember what we learned in class today is you have to have opposite variables. So if in one problem I have 3x, in the other problem I need to have negative 3x. If I have 14x, I need the other one to be negative 14x. So the same number, same variable, different sign. So when I'm looking at question number 17 here, I'm actually going to start by looking at the x's. And I notice that 6 and 3, well, I could easily make a 3 become a 6 if I multiply by 2. So I'm going to multiply the bottom equation by 2 and write it underneath here. So this will become negative 6x. 2 times 3 is negative 6. 2 times positive 3 is positive 6y. And 2 times negative 6 is negative 12. So now I'm going to erase my original equation just so that it doesn't distract us. And then I'm going to reevaluate. Do I have opposite variables? So I notice that my red x, which is 6x, and my green one, negative 6x, those are opposites. So once I have opposites, then I'm going to add the two equations. So when I add a positive 6x plus a negative 6x, that's what gives me 0, or that is where the name elimination comes from. When I add 4y and 6y, I will get 10y. And when I add 42 and negative 12, I will get 30. To solve for y, I'm going to divide by 10. So my y value is equal to 3. Now, remember, that's part of your answer. Then you're going to substitute in your variable. And you want to make sure that you do it in one of the original equations. Since I erased one of my equations, I'm going to do it in the top red equation. So let me erase this stuff so that I have some room to write. And I'm going to take this 3, which is my y value, so I might even start my ordered pair. I have the 3, and I'm going to plug that in for y here. So this equation now will become 6x plus 4 times 3 equals 42. Now I'm trying to solve for x, so I have to multiply here first. So 6x is equal to 12. No, 6x plus 12 is equal to 42. Then I'm going to subtract 12. And I'll have 6x is equal to 30. And when I divide by 6, I'll have x is equal to 5. So now I have an x value of 5 and a y value of 3. So this should be the correct answer for question number 17. Pause the video if you need to, rewatch parts of it, and make sure you understand question number 17. And then try number 19 and check your answer with the one in the book. I'm going to move on now and do question number 25. So you'll notice the directions on the second portion. It says to tell whether the system has one solution, infinitely many solutions, or no solution. So you still have to start out solving it the same. If you get something like x equals 4, then you know it's going to have one solution, and you don't have to find the y value unless you just want extra practice, which isn't bad. You could get something like 3 is equal to 3. There are no x's, there are no y's. This is when you have infinite solutions. Or you could have something like negative 6 is equal to 2, which is totally ridiculous, and that is what means no solution. So either way, you're going to have to start solving your equations just like we did in the last one. So I'm going to look at my x's. Well, let's see. I could make both of these become an 8 pretty easily. So I'm going to take the top equation, and to make it become the opposite of negative 8, I have to multiply it by 2. When I do, my top equation, which I'm going to write underneath here, will become 8x minus 14y equals 30. So I distributed the 2 to all 3 of the parts. Now, I have these 2 equations that I put a box around, and I notice that the x's are opposites of each other. So when I have opposites, then I can go ahead and add them together. So I'm going to add these 2 equations. Negative 8x plus 8x is 0. That's my elimination. Positive 14y plus negative 14y, that's also 0, so I kind of eliminated it. So I already know it's going to be infinite or no solution. And negative 30 plus 30 is 0, so I essentially have 0 is equal to 0. Is that true, infinite solutions? Or is that ridiculous, and thus it's no solution? 0 is equal to 0, so this would be infinite solutions. If there's something that you're really not understanding, so you tried number 17 3 times and you can't figure out why they wrote down a certain answer, or you don't understand my video, I want you to circle it on your paper. And then tomorrow before your homework quiz, I will give you a chance to ask any questions that you have. But we are taking a homework quiz that has 5 questions on it, and it will be a quiz grade.